Hello, Mr. Price here, and this is the second video on the Jan 2006 maths paper, and this will be on question 2, which is a projectile question. Let's have a look. So we have a golfer that hits a ball from a point on a horizontal ground, and he hits it at a certain velocity and with an angle of 25 degrees above the horizontal. And the ball's going to hit the ground at point A, and we're assuming no air resistance, and we want the time taken for the ball to travel from O to A. Okay, so let's just quickly do a sketch of what's going on here. So here's our horizontal ground, and here's our ball that's going to be hit at a speed of 50 meters per second at an angle of 25 degrees to the horizontal. Okay, so there's going to be an element of the speed in the vertical direction and an element of speed in the horizontal direction. Okay, so first we want to see how long is this ball going to take to go up in the air and come back down and hit the ground again. Okay, this is really important because then we can tell how far it's going to travel in this direction. So our first stage will be to resolve, and we're going to resolve upwards, okay, in the direction of the motion. So our initial speed is going to be 50 sine 25. Okay, it's not going to be completely 50, there's only going to be the vertical speed. Okay, the velocity, now this one's interesting. Now we know that if it's starting at rest and only gravity acting on it, it's going to go up in the air to 0 and then come back down again and travel the same distance in the same time. So its velocity when it hits the ground will be exactly the same as here, just in the opposite direction. So this will be negative 50 sine 25. Okay, it's important you do this and don't try and do it in 2 stages, just do it in 1 stage because you'll waste some time there. The acceleration is negative 9.8 because we're resolving upwards, and we really need to know the time of this. Okay, so I'll do it here, using V equals U plus AT and doing some substitutions, you should find that you get a time of 4.31 seconds. Okay, you might want to do it to a bit more accuracy in this for this stage because I'm going to be using this time, so do this to a bit more accuracy with what I'm doing. Okay, so now we know it's going to take 4.31 seconds to 3 significant figures to go up and then down and hit the ground again. So now we want to see how far it's going to travel in the horizontal motion. So now resolving to the right, we have a speed of 50 cosine 25, and we have a time of 4.31 seconds, and there's no acceleration acting on this. So using distance equals speed times time, and substituting these values in, you should get a distance of 195.3 meters. Okay, and that's the first bit of the question done. In fact, no, I beg your pardon, that's both bits of the question done. So it wanted the time for part I and a distance for part 2. So that's question 2 done. I hope that helped.